There we go. Right, now it's coming up on YouTube. And why it always starts with monetization off. Really annoying. So apparently I have 2 live chats. So which is the right one? Okay. I don't know what's wrong with the computer, bro. It crashes and there's nothing in blue screen view to show me why. CPU is like, it's warm but not like, you know, crash worthy temperatures, to be honest. Oops. There's no blue screen event. Look, nothing in here. 0 crashes. So no blue screens. It's a hardware failure of some kind. It causes the stream to crash. Pop out chat. Put that over there. See, I'm not sure why the PC crashes every now and then, but it does. Do be like that sometimes, apparently. No, there's nothing in event view either. I had a crash like this the other night while I was live. And yeah, went into event view, went into blue screen view, nothing. So basically it's as if the PC was just pulled from the mains, and then on the restart it just says last shutdown was unexpected. So it's a hardware failure. Something, it's like the motherboard is halting the processing or something. It's probably something like a auxiliary supply voltage is going too low, and the motherboard just goes no. Like it could be the 5-volt supply or something. I'm using a lot of USB power with all the cameras and stuff, so it's something like that where the motherboard's like nope, hard halt. You know, let's just halt all operations here, and it's not a software issue or doesn't give any kind of feedback to Windows about what happened or anything like that. Get my hat cam back up and running as well. The motherboard in this isn't great. It's like a little mini. It's like I think it's a micro ATX. It's quite a small motherboard, and it's like quite a low spec one. So, right, let's try that again. Take 2. All right, cool. So no short anymore. Go to 9 volts, and let's see this power up. I don't think we've got any dead. Have we got any dead output FETs? I don't think we do. No, so no dead output FETs. So just a power supply section failure, and I'll show you why I think this keeps happening on these amplifiers. It's really interesting. So I'm just going to go ahead and power this up, make sure it's not shorting out to anything on the table here. Build a little bit of rail voltage. There we go. So let's just check we have Class D switching on the low sides here. There we go, low side switching, low side switching. Okay, cool. So everything's up and running. We have the power supply. If I just zoom in a bit there, there we go. There's the power supply drain waveforms, 1, 2, 3, 4, 1.6 amps idle current draw. Now, watch carefully on the CC LED right here. So when I turn the amplifier off, that shouldn't flash. If that flashes, then that means that the amplifier is drawing some excessive current, which obviously on power off, it shouldn't do. So I'm just going to power the amplifier off now. 3, 2, 1. Yeah. So you see how that CC LED flashed. So basically what's happening with these amplifiers is there's a design flaw in the power supply drive circuit. And what happens is it's a really badly designed drive circuit here. So up here we've got a TL494, which is generating the pulses for the power supply MOSFETs to oscillate on. And then we've got a MOSFET driver here, which is this C2 chip. And this C2 chip has, on its pins, it has obviously power, which is 12 volts, ground, and then it has input A and input B down here, and output A and output B. Okay, so that's most of the pins accounted for. And then it also has an enable pin. So when the enable pin is high, or low, I can't remember which around it is, but basically the enable pin, it determines whether the chip is active or is in shutdown, is in kind of mute. It's not actually outputting the waveforms. On these chips, the enable pin is forced active at all times. So whatever these chips get given from the TL494, whatever signal it gets given from the 494, it will relay that to the power supply FETs. Now, due to the way this has been designed and the reason, because that is fixed in enable the whole time, when the amplifier powers off, the way that the power drains out of this board means that the TL494 turns off before the drive IC. And when it does that, a little bit of DC gets sent out of pins 9 and 10, which then gets passed on through the driver to the power supply FET gates. And that means that when the amplifier is powered off, it means that the drive circuit sends a bit of DC to the MOSFET gates and turns them on like for a long time, basically shorting out the power supply FETs from, basically sending a short circuit to the power supply FETs. And that's why it draws a bit of current there when you power it off. And doing that repeatedly ends up killing the power supply FETs. So we can actually see this. Hopefully I can show you this happening on the oscilloscope. So if I go ahead and probe the gates here, I'm going to probe this gate right here. Hopefully we'll be able to get the scope turned on in a way that I can show you this happening on the screen. So let's go to the scope and let's figure out what exactly settings I need. So we're going to power the amplifier up. Okay, so we've got it powered up, and let's get the scope there. Okay, now if I put this onto normal, hopefully we'll be able to see that little pulse. Okay, now it's a little bit off the screen, so I'm going to try again. I'm going to zoom out a bit further this time. Nope. I can't remember how I got it to display on my scope. Maybe it's single? Maybe it's single. Nope. Let's go for roll. Here we go. This should show it a little bit easier. So if I just have this rolling like this. So here's our PWM, and then off. It's not showing it. I need to zoom in a bit further. Up, up, up. I need it on normal mode, but I just need it to not reject high frequency, noise rejection off, coupling on the downslope. No, it pauses too soon. I can't remember how to get my scope to show it, but basically there's a period, there's a little pulse on the end of the waveform there that is much longer than those power supply pulses, and it causes the power supply FETs to short out. Now the solution here to fix this, the first batches of this amplifier to be released were using, so obviously this drive IC has been remarked, it's rebadged. It's probably an IRS 4427, which are very fast to turn off. But some of the drivers that I've tried to use in the past, which are compatible with the 4427 in every way, are a little bit slower to turn off. So they magnify this issue, they make it even worse. So using a 4427 that's very fast mitigates this issue. But we don't want that issue to be there in the first place. So the correction would be to tie the enable pin of this driver to something that goes high or low when the remote is removed. You could even tie it to the remote wire itself, perhaps, if its enable low is turning the chip off. You could do something very simple like that. So that's going to be the solution to this. But yeah, really annoying. But this is technically fixed now, but I need to do some mods to it to get that design flaw corrected. Let's go back to auto level and check low frequency. Yeah. And if I can see it, if I turn this onto line. Just disappears too quickly, innit? Maybe I need to change the trigger level. Nah, I can't remember how to get it on the scope, but yeah, basically that's what's happening. So that's what we're going to have to look at some point, but right about now that is sort of fixed. It's all oscillating correctly, just need to correct the design flaw. So let's move on to the next amp. Hope you've been well, man. Yeah, I've been pretty good, bro, not too bad. Just cracking on with life as you do. Let's just put this down to one side. And let's next of all have a look at this thing. Now this is a plate amplifier from a Vibe amplifier. So monoblock amp. This will be like inside the sub box basically. Got power in. Where's your power in? 12 volts from ground over here. Where's your remote? High input. Does it just do it off signal? There's no remote. Interesting. Fair enough. I guess it's signal sense only. Low input. Right, so what's wrong with this then? Let's have a look. So you do a quick little visual inspection first. So, just like any other car amplifier really, we've got our power supply FETs over here, got our output FETs over this side, with our output inductor. What kind of drive architecture is this using? We've got... okay, oh yes, this is basically like... the loudest.com or Bassface or Audio Bank. It's generic Chinese Class D using the optocoupler for low side drive. Or is it high side, whichever one it is. But yeah, it's the optocoupler style Class D drive. Output FETs tend to fail in these quite often, just randomly. So I'm going to check the output FETs first, see what the jam is. What's your opinion on them plate amps? Well, yeah, it's pretty meh. It's not very much power, but a lot of these style of plate amps will just be Class AB, really inefficient and like 200 watts. This thing is probably actually going to be a reasonable amount of power for its size. I suspect this is probably going to be like 800 watts maybe, something like that. Which is, you know, better than most of these types of things. Okay, no shorts on the output section here. Okay. No shorts on the power supply. Okay, let's get it fired up and see what's the issue with this end. Let me just remind myself, what did the customer say was what's wrong with this? Can you remind me what the issue was with the Vibe plate amp, buddy? Question mark. Let's get some power wires going in here. Matthew says, yo, just got finished with the room. Nice. I'm glad it sounds a lot better. I thought it would do. I thought it would do. Florida man, how's it going, my man? Thomas, how's it going? I'm good, bro. I'm doing well. Have you got a USB riser card yet? No, because I don't have any PCI slots that are free. That's what I mean. So like the PC is maxed out basically at the moment. Everything is in use. I can't like add anything extra to it. So I need a new build to add more USBs and stuff. My mum can't hear it so much. Oh, good. Yes, of course the carpet will massively help with that. So that's a bonus. Moto Arki says thanks for the advice on my amp. No worries, man. Always happy to help where I can. So I've got a bit of signal going in, a bit of RCA going in. So let's turn the power supply on and just see whether this comes on. There's no, like I say, there's no remote in on this. Just seems to go signal sense. First time seeing one of these, so. Okay, so we've got 0.2 amps of current draw. Yeah, there we go. Got a blue light, power. White light, if I should say. So 0.6 amps worth of current draw. We have Class D switching, yep, so that's oscillating, it's working. Okay, cool. So given that we have signal going in, we should actually have some audio coming out. Level, here we go. So we should actually have a bit of audio coming out of here, but I didn't see any wobbling on the Class D waveform. So do we have any audio? Oh yeah, it's working fine, bro. Hey bro, it's working fine, huh? Wop wop wop. Okay, it's working fine. Well, let's just check, go up to 12 volts. 14 volts, yeah, it's working good. Make sure that there's nothing on the other one to show ground, yeah. And then if I remove, yeah, just power it off like so. There we go. It's working fine. Was in protection, then goes out of protection but has no output. I just tested it on live stream and powered straight up, working great with audio. I can plug it into a sub and make sure that it continues to work, but from experience I can tell you that it will. Feel free to jump on my channel and scroll back about 5 or 10 minutes and you will see what I did. All right. Luna, how's it going, man? Blue on Bus season 2. Yes, season 2 is coming. I just need to put my brain in gear and work out how I'm doing it. And yeah, but definitely a season 2 is coming. But first of all, I need to do a roundup of season 1. So I need to finalize season 1, get that out of the way. But yeah, as soon as things quieten down a little bit in the workshop, things seem to quieten down a little bit over the sort of November and December time. So that's when season 2 will probably be. Let's take a little look now then at this one. This is a JL Audio JX500/1. I thought this was the 250, but it's the 500. Godfrey, how's it going? Do you have a regular pattern live stream? Nope, not in the slightest. I literally decide whether I'm streaming or not about 5 minutes before I go live. It's just completely sporadic and completely random. I won't be able to stick to a schedule, I'm afraid. No chance. Yeah, so this is 500 watts RMS into 2 ohms, I believe. If my memory serves me right. So 2 ohm, 500 watts. And it's not constant power smart tech like the Slash series is. Okay. Now this one I've repaired before, and I think if I remember rightly, the guy wired it up and it blew straight away again for some reason. So that's a bit strange. Let's try and figure out what happened there then. So okay, let's first of all check the FETs. I think this was a power supply rebuild, this one. Okay, yes, we've got dead power supply FETs again. Interesting. Very strange. The power supply sections in these are a different style of circuit design. They are what's called a flyback power supply, so they work differently to a regular power supply section. Well, actually, no, I think this one isn't. Actually, I think this one might not be a flyback. I think this one might just be regular. Like regular push-pull, actually, because it's got a transformer, not an inductor. So the FETs that were used in this are the IRFB 7540s. I wonder whether the startup initial current was too much for these and spiked it with the gate resistors that are used. Let's pull the board out of the case completely and let's have a little inspection underneath and see what's going on there. Now, so this apparently blew up when it was powered up, so it wasn't really anything to do with the load that was connected. Can you send a YouTube notice? I don't really know how to do that. YouTube should just notify you. If it doesn't, then that's on YouTube, not on me. Have you ever built a discrete input input card? No, I haven't. So this is using original output FETs. So it's just a power supply failure. So I wonder whether this has a shorting power supply transformer that I didn't notice. You know, that was fine for me, but then got knocked around a bit in postage and is presenting a short again now. So yeah, let's investigate this a bit because This is blowing the power supply twice now without any sort of output side short, so there's definitely something funky going on. Yeah, this isn't this. Sorry, that was my apologies. This isn't using a flyback style power supply. This is just using a regular one. It's the JX1000/1 that uses a flyback power supply, whereas the 500 here just uses a regular push pull. So that's my bad. I could send a ping on Discord. Yeah, I guess I could do. Don't really use Discord much. Yeah, this is a little half bridge. Yeah, not that makes any difference. I'd actually probably prefer it if it was a full bridge. Is that all the screws? Why is this not coming out yet? Ah, couple of screws on the side there. Mike, caught you live again. YouTube never notifies me. Yeah, it's just a YouTube thing. What I realized is that when you click for notifications on YouTube, that doesn't mean that it's going to give you a push notification. That just means that it's going to give you a YouTube notification, which it will do in the little YouTube notifications bell thing, but that doesn't mean that it's going to actually give you a phone push notification. So right, the drive circuit for this is down here. Now this was pretty burnt out before. 4R7, that's burnt out again, so this is probably going to have a dead driver as well. Now this is really frustrating actually, because this driver isn't something that is common. And it's not something that I have in stock all the time. So I might just have to see whether I ordered more than one of these or not. Frustrating. Why have you died again? It's in the same package as like a 4427, but it's not a 4427, it's like something else. Audio is coming in and out really bad. Has anyone else got any issues with the audio coming in and out really bad? Must be something to do with you then, bro. Your speakers are screwed, bro. Living loud. Something's wrong with your audio setup there, bro. What do you think of DS18? Not a big fan in general, but they do sell some okay stuff. The thing that I don't particularly like about DS18 is they're one of those companies that's done absolutely zero R&D themselves. They may have done it in more recent times, but definitely when they introduced themselves to the UK, they appeared on the audio scene out of nowhere with a massive catalogue of products, like absolutely huge, like 10 times more than your sort of DC Audio, Sundown, DD, that kind of brand were offering. And when that happens, you know that it's basically just like Alibaba, everything the factory has to offer on the catalogue. Having handled some of their equipment, I've not been that impressed by the quality of the stuff, like the kind of assembly quality. But yeah, all the amplifiers are just generic. They don't design their own circuits by any means, and I'm almost guarantee they don't design their own loudspeaker drivers either. So, not a massive fan. do customers really tell you what actually happened after receiving a repaired and tested amp, or do you end up digging out the truth? So it's honestly quite rare that I get anything back after repair, just because I sort of go through things quite meticulously and I test things properly. But it does happen on occasion, like with this one. So this one, I know the guy quite well. I know that he wouldn't like make a mistake and then pretend that, you know, that he didn't. So this amp was repaired, tested, and sent back, and upon plugging it in and turning the remote on, it blew the power supply fence again. So it's obviously an issue that either didn't present itself to me in the workbench that I've missed, maybe like a shorting transformer that didn't notice it wasn't shorting to me, or something else, like for example, these FETs that I fitted are upgrades over the originals, but it's possible that when the amplifier powers up with a high current, like from a car battery, something about this circuit is different and it's unhappy. So I'm going to go back down to fitting 3205s in this now, rather than using the upgrades that I spec'd before. What happened with Boom or Bust? Yeah, Boom or Bust is coming back, but it wasn't making enough money for me to continue doing it in its current form. So I'm going to try some changes to it, see if we can get the views up a little bit. Yeah, I'm glad you guys enjoyed it. Definitely the people that watched Boom or Bust definitely enjoyed it. It just wasn't making as much of a reach as I'd hoped, in terms of like new viewership and stuff like that. But maybe it will do for season 2, who knows. So I'm pretty sure that the driver here is screwed. We definitely have an open 4R7, which probably means the driver is screwed. Drop in a new 4R7. So I suspect if I measure the resistance between the 4R7 and ground, yeah, we do have a short, so that's the driver. Lovely. This driver, if I remind myself, what is this? And I'll see if I've got a spare, because I had to order this one specially. So hopefully I ordered more than one. remind myself what it is. M18021. Let's write that down in Notepad. M18021HN. Right. Do you still have your big bass build? I've still got the van, yeah, with the 2DD Z415s. Still got that. Don't really use it. Could the uprated FETs have caused something else to blow? So using uprated FETs won't have caused something else to blow. However, the FETs that I used might not have actually been too happy in this circuit. That's always a possibility. Especially if there's no soft start on the FETs. Sometimes FETs with higher power ratings actually, surprisingly, aren't as kind of rugged in terms of like instantaneous, sudden like spikes of current. Because they have lower RDS, the kind of really short spike of high current actually ends up being a lot more energy throughput through the FET because it's a lower RDS than something that's a slightly higher RDS and more rugged. So that could be a possibility. So we're going to put some 3205s in, which are tried and tested in this circuit. And that should hopefully be it, but yeah. Right, so in terms of the driver, let's see. Where would I have put it if I had multiple? I'm going to check my emails for that code and see whether I ordered more than one or not. So that was a M18021HN. No matches, probably because it's not the exact. That's Google mail search is actually terrible. Unless you search for the exact part number, it doesn't actually show up. Like if I search for 3205, it won't show 3205. If I search for IRF 3205 PBF, then it shows all my orders of 3205s. It's really annoying. Let's type MOSFET driver and let's see what comes up. Okay, that was a while ago. Driver? What? Surely not. Driver. MOSFET. Maybe I search for SOIC. Here we go. When did I repair these for this guy? Previously. Get the date right. August, July. First of July, I think it is. Okay, let's have a quick look back. July, June. No, this is April. No, I'm not finding it in on my emails anywhere. Right, where would I have put it if I had put it somewhere? 18021. that. Not that. Not that. Okay, so it's none of these. What I'm going to do is Google that number, which will then hopefully give me the full part number, which I can then search my emails for to see how many of those I bought. Driver. Ah, MP, there we go, that's it, that's what it is. So let's try searching my email for that. MP 18021. MP 18021. Hey Jen. Nope. No, but interestingly, a Hertz HDP1D amplifier uses the exact same driver because I just found it on a schematic. Okay, no worries. Let's see if we can buy one of those. There we go. I think that's it. No, MPQ. Let's just check that's the same. High drive, low drive, VDD, BST, drive high, switch, drive. Yeah, I think that's correct. So that's the same. Just make sure the pinout is the same as the MP in comparison to the MPQ. So we've got VDD, BST, drive, switch, in high, in low. Yeah. Excellent. So they can still be purchased. So we're going to need a new one of those for this amplifier. So let's put this down to one side. I have to await some parts on that one. Let's put some of these in a bag before I lose them. Actually, where was those parts? There we go. This is the parts for the JL. These were for the base face. And these ones were for the smart. I've got a Big Boss 3 in for repair actually, which had an interesting fault, which we think is a factory defect, not like a circuit design issue, just unlucky bad parts. Can you help me diagnose my amplifier? I'll do my best. It's quite hard over the internet, but if you want to send me a message, facebook.com/bearvids. Send me as much information as you can about the fault you're experiencing, and I'll do my best. Okay, next amp on the bench we have this GT 1100-X1 mono amplifier, number 7. The upgraded FETs were IRFB IRFB. Fuck, what were they? I've got them here. Don't I throw them in the bin already? They were 7540s, I think. Yes, IRFB 7540. I think that's what they were. Actually, I don't think they're specifically upgrades. I think they're about equivalent to a 3205. Legit question, are IGBT's FETs actually bipolar? How does it work if they have diodes which only allow current one way? They're not bipolar. The diode is to prevent massive spikes when IGBTs are being used in switch mode application. So what we've got here then, we have your standard typical Chinese layout with the optocoupler. So we're going to see, yep, standard procedure on these dead output FETs, one there, and any on the other side. I think this one might just have one single dead output FET, which we can check the drive circuit health of by just removing that one dead output FET and powering it up, because it will run with just two FETs in this side. Yeah, so let's power it up and see whether the drive circuit's okay before we change any FETs out. Wish I could send you pictures over YouTube live chat. That'd be great, wouldn't it? YouTube needs to allow that. I don't know how it'd be moderated though, because you could send in all kinds of, you know, dodgy pictures. So it'd have to be moderated in some way. Maybe it can be like, yeah, so basically mods, or me or mods on the chat can like allow pictures. So basically you submit a picture, it then gets sent for review, and mods can then accept it or delete it. That would be great. Why is the board so empty? You know, this is just your kind of like really budget end amplifier. So I suspect there's a little bit of spreading out of the components deliberately to make the amplifier seem bigger than it otherwise needs to be. Because yeah, this could definitely be about half the size if everything was kind of put together a bit more. It's probably to make the amplifier seem a bit bigger from the outside. So I'm just going to start off with 9.5 volts. This camera seems a little bit dim now, doesn't it? Let's see if I can sort of brighten up a little bit. Go for some filters, color correction, gamma maybe, brightness. This is kind of washing it out a bit, isn't it? It's not the best camera, this one. So I think this is low side over here, so if we just go for a power up, zoom out on the scope, reject low frequency. There we go, so drive circuit's all fine, it just had a single dead output FET, so nice and easy to fix. But we will obviously replace all 6 output FETs, because there's only 6 of them, you might as well. There's no reason not to, really. Just wait for that rail voltage to sink down a little bit. Yeah, these amps are like the easiest ones to fix. Guys, if you ever want to get into fixing amps, this board layout is your route in. This is your way in to repairing amps. Really super simple. They only ever really have like the same, you know, the issues that these get are the same every time. It's either just FETs or it's FETs and drivers and gates. Really easy to learn. Power supply is always FETs, gates, drivers. Yeah, really easy to just keep knocking these ones out. The Crown power amps in the background for sale. Would I ever sell those? Maybe, I don't use them. I would consider it, but I wouldn't sell them outside of the UK, just because the postage would be expensive and it'd be too risky, and I would definitely have buyers from in the UK, so I wouldn't want to ship them outside of the UK, unfortunately. I got a DM 1500 that I bought. Bro, please learn this. No offense. This is just one that really grinds my gears. You know, there's always that one thing that you see repeatedly misspelled online, and it's just one that just really gets on my nerves. You bought it, bro. There's no R in bought, but you bought it with some missing parts, input capacitor, and a couple more stuff. Are you familiar with those? The DM1500, I think, actually is this same circuit design. Yeah. Although the DM1500 has the twin optic coupler, but yeah, basically exact same circuit design with the same driver card. So yeah, they're really easy to repair. Input capacitor, you can, if it's missing an input capacitor, one of these ones over here, you can pretty much just drop in something like a 25 volt, 4700 microfarad. If it's missing one of the caps, it's not super critical. They don't all have to be matched. It's just to offer some buffering, some kind of buffering for the 12 volts coming in before the transformer. It prevents transformer ringing from going back down the vehicle to the rest of the car. I'm interested in both the crowns if you sell them. I'm in Cambridge, England. I'll consider that. I won't be selling them like super cheap. I'll be selling them at market value. Condition wise, one of them is pretty good condition for its age, to be fair. It's actually really nice. That's the crown one. The Amcron one is a little crusty on the outside, and the speaker terminals are a little bit fiddly. But internally, they're both sound, both absolutely solid internally. I had them serviced a while ago, quite a long time ago, before I was doing amp repairs, by a guy that literally just specialised in Macrotechs. I wonder how he's doing, actually. That was a long time ago. But yeah, he was like the Macrotech guy, and he sorted them all out for me. Correctly biased, correct matched outputs, all that jazz. Ah, 4-stroke. You don't have to delete your message there, bro. It's cool. You miss your crown amps. Yeah, they are good, bro. They are nice. Right, how are we doing on rail voltage? 8 volts. Yeah, that's fine. Should be gone now. Nice. Let's get these FETs out of here. I'm not actually going to bother taking this one out the board, just because the thermal mass of these boards are so low that you can just like straight up solder from the top, very quick and easy. And we know that the amplifier works because we just powered it up. Just needs one FET replacing, but we're going to do all 6 while we're here. Macrotech 12K. I have dozens and dozens on for my Stadium sound stuff. Good stuff. Yeah, the crowns are good. They are old now though. There's definitely better, more efficient circuits you could go for, but there's something a bit magical about them, isn't there? I suppose people have nostalgia for them as well. I saw a dude not far from me in Newmarket selling some Macrotechs, but he wanted near £1,000 each. They were battered, never serviced. What models were they? Were they the 5000s by any chance? Right, some new 640s. Let's get the same batch. Make sure that we are using the same batch for all of these. JDDO. HCX, X. There we go, 6 of the same batch, lovely, lovely stuff. Any idea why in this particular design love to smoke output FETs? I've never really sort of done a lot of digging into why. In the older designs of these, the outputs are driven very, very poorly because the drive is run through, well, I was going to say, I think it's because the drive is run through optocouplers and they're very, very weak, but it is buffered, so I'm not really sure. But the low side drive and the high side drive always looks really, really bad, like very, very curvy. Not very sharp, so the output FETs are kind of soft switched, which is going to limit their current throughput per pulse. So I thought it was something to do with that, but I haven't really done too much of a deep dive onto it, just generally because it's not worth it. You know, the amount of time and effort into R&D, that massive daddy long legs. Go away. Did you see that? Just like land on the desk there. It could be that. It could be just poor current sharing between the output FETs on these. Could just be people clipping the absolute balls out of them because they're very cheap and tend to be purchased by people with not great experience. Because I have seen ones of these circuits that last a really long time, like years and years and years. But when they fail, it's always just output FETs that just pop. So it's probably a combination of poor current matching, weak drive, and inexperienced users mostly buying these. It's the same design as the Scar RP2000. Yeah, basically the same design. Ended up getting a rack of QSC PLXs, but honestly I don't really like them very much. I find the QSCs with the SMPS just lack compared to their amps with the traditional transformer. It's interesting that, because like they shouldn't do really. There's nothing really about switch mode amps that you know, would lack. I wonder if it is just a mindset thing. I don't know. Do FETs just fail on their own? Yeah, they can do. They certainly can do. It's a bit like a light bulb just failing by itself. Things have a set sort of lifespan, or they have a certain number of heat and cool cycles before their specs drift far out of tolerance. I have one Class AB amp, gets quite toasty under load and isn't very efficient. Any particular reason why it's like that? That's just Class AB stuff doing Class AB stuff. Yeah, they sound nice, but they're very inefficient, and yeah, they'll get absolutely cooking under any sort of moderately heavy load. That's just Class AB for you. That's the drawback. My Macrotechs get pretty toasty running subs at low impedances, but that's just Class AB for you. I know the Macrotechs are technically like Class H or Class GH or whatever it is, but they're still essentially a Class AB. Alright, let's drop some new FETs in here. 6 new 640Ns. Where's my thermal paste at, bro? Here it is. New thermal paste. You love to see it. 1, 2, 3. Dip. Dip. Greetings from Florida. How's it going in Florida, my bro? You need a thermal paste dispenser gun, so much cleaner. Don't get it all over yourself. I 3D printed one. Hey, that's a good idea. Might give that a go. Yeah, thermal paste gets freaking everywhere, and when you get it on your clothes, it doesn't come off either. Okay. Your clothes will transmit heat well. I think it works quite like that, my bro. 93 degrees out. Damn, that's very, very close to the boiling point of water. How are you even still alive? Right, check the gate resistors on this side of the one FET that was dead. So, gates. Yep, it's good. It's good, so this should just literally power right up now. What the hell is a kilometer? Low side drain. So switchy. Boop. There we go. 12 volts. Muy bien. 14. Oh, by the way, guys, do you want to see a design flaw on these? I've already let the manufacturer know. So on this specific design, okay, when the voltage rapidly goes up, so let's say the voltage rapidly goes from 12 to 14, watch what happens to the Class D switching. It disappears. Let's go from 10 volts to 13 volts about. So yeah, when the voltage rises, Class D switching disappears. Boop. That is a design flaw. All of these do that. This isn't like a failed repair or anything like that. It's to do with when the rails increase from the increased voltage going in, because the voltage is tied, the rail voltage is tied to the power supply FETs, which then causes more rail voltage when you go up in voltage. The rails moving like that cause the auxiliary voltage for either the low side or the high side, I haven't honestly been bothered to like look into it, to shift relative to ground enough that that voltage isn't present enough anymore, so the drive circuit just turns off for a minute until all the voltage is stabilized, and then it comes back to life. You'll have to see it. Okay, let's get the back on this. Where's the back? Where's the back? Here it is. That's good sound. England, the only country where we measure fuel quantity in litres, but then measure fuel consumption in miles per gallon. Yeah, that doesn't make any sense. That kind of does my head in a little bit. There's a few things that we do like that are kind of stupid. Okay, that's this one done. Next one, is looking like another one of these 1500 X2s. So I suspect this is going to have the same issue with a blown power supply section. Oh yes, it smells like a blown power supply section. Oh man, I've got 2 of these daddy long legs in here tonight. Man, these things be cray. Where is it? Where is it? Oh, it's up. Oh yeah, can you see it? Can you see it? Crane fly, I think that is. It's because I got the window open and I got like the bright ass lights in here. I've got one that's landed here and is just literally chilling on my wire. Apparently these are the most venomous or most poisonous or whatever it is things to exist, but they don't have a stinger, so they can't sting you with it. I don't know. Yeah, they really annoy me, those ones, because they're kind of like, and they just kind of like bump into you and like, it's like, oh my god. I'm not scared of them, they're just kind of annoying. What the hell? Yep, blown power supply. I suspect, do we have blown outputs? Probably not, because these ones all kill the power supply. Nah, man. Output's fine. So, design flaw again has killed this one. I wonder whether we're going to be able to see the gate drive break down on this one. On this one, I'm going to remove the FETs and power the gate circuit, the drive circuit up without any new FETs fitted to see if we can see the issue on the scope. Oh dude, thanks for the 199, Damon. Appreciate that, man. That's very kind of you. Get myself a drink maybe with that. I get myself some parts, get myself a few FETs. Thank you very much, my friend. Very kind. Sam, don't you know? Sam, I don't know you. No, don't know about you, but I think we are similar age. I was never taught feet, inches, pounds, ounces yet. Like you say, I buy fuel in litres, yet I drive to mile an hour, miles per gallon, and I'm 5'11". Yeah, what year were you born, my friend Mike? Yeah, everything's all a bit mixed up in the UK. We use metric for most things, but then some things we just don't. It's kind of like where. Do you need a license to watch TV? Technically, yes. So the reason that we need a license to watch TV is because I don't know if this is the case in America, but television never had adverts. Adverts weren't a thing, right? So to watch TV in the UK, there was originally one channel when TV first came about, which was the BBC, British Broadcasting Company. I don't know what it stands for. Anyway, the BBC was the channel that you'd watch, and there were no adverts. So in order to watch the BBC, you had to pay a yearly license in order to receive the broadcasts to, fund all of the technology and all of the costs associated with providing a TV service. So that's how you paid for your TV, via license. Then you obviously had BBC Two and ITV. Oh, sorry, you had BBC One and BBC Two. Those were your two channels, and you didn't have adverts. Now, ITV, which was the third channel, came about, and ITV was different to the BBC. ITV got its funding through advertisements. So for the first time in British history, you had adverts on TV on Channel 3, which was ITV. And this was kind of something new and different for the people of England, was adverts. But even though, so still to this day there aren't adverts on BBC, I don't believe. BBC channels don't still to this day have adverts, but all of the other channels on Freeview obviously do have adverts. ITV, Channel 4, Channel 5, and literally the hundreds of channels on Freeview all contain adverts. Just BBC doesn't, I believe. Although I'm pretty sure the BBC iPlayer has ads, so go figure. But for the duration, the TV license has remained, which is really freaking stupid and outdated as heck. A lot of people don't bother paying it, and in order to get done for not paying it, somebody has to come round and give you a visit, and they have to prove that you've been watching licensable, chargeable TV shows without the license for you to get done. And it's really easy to get out of it. You just either don't let them in for the inspection, or you just don't have an aerial connected to your TV, and you don't have, I think you have to have a TV license to watch live stuff on BBC iPlayer. So just don't have that on your PC, I guess. So you only have to have a license for watching live broadcasts on TV. And that does include live broadcasts on the internet as well. From not like YouTube and stuff, just from like your TV channels. You know, they have like a website that you can go to and watch live. You technically need a license for that, but a lot of people don't bother with it these days. You can get big fines for not having a license and being caught watching stuff, and people do get made an example of. People do get done for it, but it is pretty rare, and you have to be kind of a bit stupid to be caught for it. Oh, dude, the English Miner, £4.50. That should buy you a Freddo. Thank you very much. That will just about buy me a Freddo these days. Thank you very much, man. That's very kind of you for the £4.50. I appreciate that. Yeah, there have been people that have got done and had to pay money for not having a TV license, but it's questionably legally enforceable. Hi Sam, how are you? Have a chance to buy a B2M M1U for £900. Do you think it's a good price? No, I do not. I wouldn't buy that if I were you. That's a lot of money for something that you can get the same performance elsewhere for a lot cheaper, even brand new. So no, I wouldn't buy that. Yeah, the TV license is one of the stupidest, oldest things that remains a thing in the UK. I doubt it will last too much longer. More and more people are not watching TV. Like, a lot of people my generation just don't watch TV. On TV, they just watch YouTube and streamers and Netflix and that kind of thing. So I suspect it won't be around for too much longer, but it's just a stupid thing that it originated in the olden days when it made sense originally, and it's just kind of stuck around, even though the landscape of consuming media has drastically changed since then, and it is massively outdated. But yeah, it's still a thing. But at least we don't need to. At least we don't get charged with a bill if if we need like some. I don't want to get into politics and stuff. I don't want to get into that, but I am quite appreciative of the UK healthcare system. Even though it's not great at times, at least it's there. Like I don't ever feel scared to dial for an ambulance. If I see somebody on the floor, like, it never crosses my mind, oh, wait, hang on, should I call this ambulance? It's like, no, you just call an ambulance. Like, I never have to think twice about like going to ask about some healthcare thing that I might be concerned about, that I just want to double check. I never have to worry that I'm going to be lumped with some crazy big ass bill or something like that, or that my insurance isn't going to pay out or something. So that's one thing. There's swings and roundabouts and pros and cons to everything, so. Dishan says, get a screen without a tuner, basically a monitor. Yeah, so that's basically what I have. I just have a projector, so that's basically what that is. But if you somehow get caught watching BBC iPlayer, they can still do you for it. Yeah, there's a lot of strange stuff, but you just got to kind of make the best of it, haven't you? %75% of people that have a TV license don't actually need one. I think it's one of those things that people just get because they don't understand whether they need it or not, and they're just a bit scared about doing something wrong, so they just get it anyway. British people are a bit like that. Like I feel like a lot of the British population are very, very easy to scare into paying for something that they probably don't need. What's up, Dr. Diner? Surprised you haven't invested in a desoldering station yet. Oh, I have, my friend, but don't really get along with them too well. I find it just quicker to use the manual pump, to be honest. Right, let's have a look at these gate resistors. Do these all need changing? These all actually look fine. That one there looks toast. Yeah, a couple of these look toast. Alright, these gates, let's have a look. Got 32, which is correct, 42 in parallel. This one's toast here. Yeah. I thought so, but I just would double check. Cool. Heat gun, flux, new gate resistors. And we need 1, 2, 3, 4. 1, 2, 3, 4. Last one. Now, so far on these, all of the drive ICs have survived, which is kind of interesting. Okay. So let's shove some power into this and let's see if we can see on the scope the glitch which causes these power supply FETs to fail. Okay, so power on, and let's give you the scope screen. Let's check we have PWM. There we go. Oh heck, that doesn't look good. Okay, we've got 12 volts actually on one of those. I wonder if I've got a solder bridge. That's probably my bad. Yeah, I've got a solder bridge. I forgot I hadn't cleaned up the underside of this board yet. Trying to rush things too much. That's better. Right, let's try that again. Okay, now so the driver did get damaged in this case from the failure. So we need to drop a new driver in there, which I don't have. I have ordered some 4427s, but they haven't arrived yet. So I don't think we can see the glitch on this one, unfortunately, until that arrives, but we can remove the driver. Oh, actually, I think I can see the burn mark on this driver here. This one has definitely failed. See, it's got like a little dark spot in the middle there, a dark mark. Right, who remembers the QSC amplifier we were repairing a while ago? That had the blown auxiliary supply circuit for the switch mode power supply. Does anybody remember that one? So basically, I had an amplifier repair in a while ago it was a QSC PA amplifier, and it appeared to have, well, it didn't have any power at all. You plug it into the mains, turned it on, no life whatsoever. And we found out that it had a blown transformer for the auxiliary supply plus 16 volts that powered the SG3525 oscillator and the 2110 MOSFET driver for the IGBTs that were for the switch mode power supply. So I ordered and replaced all of those parts. The chip that generates the oscillation for the little transformer to generate plus 16 volts auxiliary, and everything else looked fine and tested okay. So I plugged it into the mains, and I shall show you what happened. We go to media source 2. I'll find the video that happened. Here we go. This is what happened. Jesus fucking Christ. So yeah, she went pop. That was the IGBT in the switch mode power supply exploding. So I looked it up. I couldn't see anything really that I'd done wrong. Yeah, the IGBT is just the second the IGBT got told to oscillate, it exploded. There's no shorts on the output side. There's no shorts on the rail for the IGBTs. So it must have been that perhaps the IGBT driver, the 2110, failed, which caused the auxiliary circuit to fail, which I didn't catch, or it didn't show a short or anything like that. So when I repaired the auxiliary supply circuit, the 2110 was still damaged and caused the IGBT to fail. So I've now fitted new IGBTs, fitted new 2110. There was a couple of diodes in the drive circuit that were failed, and also the PWM generator, the flip-flop, has also failed. So I'm waiting on a few parts for that until I try and power it up again. So that was really annoying that happened. Okay, so what do we have next? I've done all of the amplifiers that I had brought up from downstairs. So I think that's probably it for now. I could do some Q&A. I could go and get some more amps from downstairs. maybe I should go and get another couple amps from downstairs. How are we doing on the stream? Oh yeah, 88 viewers. So guys, all 88 of you, just hang fire for a minute. I shall go downstairs and grab some more amps to repair. Just bear with me for it. Just waiting for when you're going to dig into those cram macro checks in the background. They're not blown. These work perfectly fine. These are just my test amps for when I need to test a big sub or something like that. Nothing wrong with those at all. They're perfect. What liquid flux do you use? Can't seem to find a decent type here. Doesn't leave residue. This does leave residue, but it's not conductive. This is chip quick. It's really, really good stuff. I wouldn't use anything else. So I'm just going to go and grab some more amps. I'll be back in a minute. Okay, got a couple of stankers here. These are rattling around like crazy. Something rattling around in here. Let's get this plugged back in. Let's just reset this one. There we go. Okay. So this one says MOSFET burnt. Okay. Now this is a class GH amplifier. This is basically class AB up until a certain point, and then it switches the rails. It said MOSFET burnt. So let's see what we can find in this. These actually have been a bit of a headache to repair in the past. And these also use an MCU, which is programmed in the factory. So if that's dead, then these are a bit not repairable. This one has been taken apart before by somebody else, by the looks of it. I don't really like it when that happens, because you always, I like to see the amplifier in its original state when it failed, if that makes sense. Some screws and some parts. Oh yes, we have blown power supply FETs over here. That's usually what fails in these, to be honest. So let's get this out of the case. Doesn't look like anyone has attempted a repair on this, just that they dismantled it. Which I still kind of find a bit annoying, because I like to see the amplifier in the exact condition when it failed, because it helps to identify why. There we go. So, yeah, pretty toasted power supply section here. Let's cut all these out. Now the drive circuit on these is over here. It looks like this driver has a big hole in it actually as well. This needs a 4152. So we're going to need new driver. Looks like that resistor might be a bit burnt there as well. All these drive transistors, I think these are just covered in soot from the failure. I don't think any of these are actually burnt over here. But this drive chip is definitely failed. I don't know if I've got any of those. It's been a while since I've repaired one of these specific units. Good night, Latvian. I hope you sleep well, my friend. This one's got a bit of thermal mass, so I'm going to blast this with the heat gun in a minute to get rid of the source legs, because they have a bit of thermal mass on them. Luna says, "Hi Sam, I just sent you 15? Dude, that's a lot. Why did you send me 15 for, bro? How did you send me 15? What, on PayPal or something? That's super, super kind of you. Thank you so much." Gallon says, I don't accept repairs opened by somebody else. No, I understand that. It just kind of feels a bit janky. Oh yeah, 15.33 GBP received. My guy, thank you very much. That's very kind of you. Awesome. That'll buy me about 5 Freddos. Good job. Thank you very much, my friend. Appreciate you. First time we're seeing a Class GH in your stream. What do you think about them? Yeah, so I like the concept, but it's unnecessary for a subwoofer amplifier because the benefits of Class AB, or the kind of Class AB transistor output style, will be reaped on full range audio better. For subwoofer application, honestly, Class D is like absolutely fine. So it's kind of unnecessary, and I'd much rather go for a smaller, more efficient Class D, or a more powerful Class D over a Class GH for subwoofer application personally. So this is looking kind of janky, hey? I just want to, is this ground trace on the top of the board or on the bottom? Because there seems to be a bit of thermal mass on these. I haven't checked the output section of this yet to know why this failed. Just kind of rolling with the flow. Just removing all these burnt parts that we see here to start with. And then we're going to sort of try and look into maybe why this failed. Let's hit this with a bit of thermal energy. Man, these are really stuck in here, hey? I think what's happened is the FETs have got so hot. Sometimes you get this where the kind of legs actually almost weld themselves to the metal of the via. Sheesh. Can you show the switching rails on the scope? Yes, definitely, provided... actually, I don't know, because this needs a new driver for the power supply side. I don't know if I've got one of those in stock, one of the specific drivers that this takes. So I don't know if I'll be able to get that up and running to show you the rail switching actually taking place. But we'll see. Man, let's see if I can even get these freaking legs out. This is becoming a bit of a pain. Holy hell, I think this is actually welded. This is more than hot enough to melt any solder. What am I going to do here if it's welded itself in from the heat? Do you know the top right IC is on the output driver card from this Korean amps? The card has the IR2184. So a lot of the time, both of those chips are both TL072s. But sometimes you get ones that have the LM211. There's two different types, and they look very, very similar. Yeah, this is just not happening. Alright, I'm plugging in the big soldering line, the 200 watt Weller. Ah, okay, getting a bit of success pushing them through from this side. Here we go. Just this one is just not happening. So Jason, don't just try one or the other because you might cause more issues. Best to find out for certain which style it is, because you might have other issues that are causing it not to work and not the fact that you've got the wrong chip. Alright, let's bring in the big guns. What are we saying, bro? This one I think is actually welded, like, yeah, the whole board is like moving. There we go, holy bananas at last. Straight up, yeah, good to have you here, bro. What a mess. What a mess. Isopropyl spray. So we can clean this up a little bit. Hello from the States. How's it going, my friend? Okay, we have holes. Excellent. Now, gate resistors all need to come out because they're all cooked. And this driver needs to come out because that is also cooked. So let's just, while we've got some heat in the big iron, let's just use the big iron to remove that. It's going to be this one. I'm just going to flood these legs rather than trying to like suck the solder from each of the holes. I'm just going to flood these legs up and then should just pull out quite enough thermal mass. Shouldn't be a problem. There we go. As you can see, yeah, that is toasted. Now that is a soldering iron. You are right, my friend. This is an soldering iron. This is like, I wasn't asking, I was telling. Soldering iron. Get some of the gate resistors out. I do actually have a donut. Freaking crippler. I'm not scared of them. They're just kind of annoying. I just don't want it buzzing in my face. I do have a donor board for one of these in the loft somewhere. Bro, literally, why are you in my face though? Still, not needed. Alright, gate resistors next. One thing we can do is power this up and just see whether the microcontroller has survived, even if we don't have a drive IC yet. Obviously we need to order one, but we could see whether the microcontroller has survived on this. Yeah, I won't be able to show you the rail switching, unfortunately, until we have all the power supply repaired. Remember the clone base face amp with the voltage spike on the drain of the power supply FETs? Yes, I do. Even adding a snubber network didn't help much. It's drawing 12 amps of current on standby. Hell, that's crazy. What I found worked for me was changing the switching frequency of the TL494 to something that is more within the transformer's optimal range. And that sorted it out for me. By the way, guys, I finished the audio pipe mod. Can you believe it? It's all done. I just need to drill some holes in the heatsink and then test it. But all the circuitry work is all done. So, what is this gate resistor? We're looking at red, black, silver. No, that's not right. What value gate resistor is this? Red, black. That would suggest, oh, this is a 5-band. Red, black, silver. Is that 2.2 ohm gate resistor? Why would it be a 2.2 ohm gate? Here? It's a 5-band. Red, black, silver, brown. Let me just Google that, the 5-band. Red. This is 2.2, is it? Yeah, 2.2. I was right. That's pretty low value gate resistors for a 064N. Well, I don't have any 2.2s in that package, so I'm going to drop some 4.7s in probably. Usually you'd use 47s with the 064s. So that's kind of cray. Or no, sorry, 064s you'd usually use 22 ohm. 22 ohm gates for 064s. Yeah, I think I'm probably going to drop in some 4.7s if I can find them. The tub of resistors, guys. The mix of resistors. What are you? You actually might be a 2.2. What's my test lead resistance? 0.6. Oh no, it's a 1 ohm. So they're 1 ohms. Red, black, gold, brown. I think that must be 22. Yep, these are 22s. I could just use some 22s to be fair. That's what you usually use with the 064N. Brown, black, silver. That's 1.1, I think. Tried changing the frequency up and down, no luck there either. Does the spike, my friend, only appear when the duty cycle reaches its maximum, or is the spike always there? Even during like the ramp up, the sort of soft start. Ah, here we go. What's this? Red. Ah, these might be some 2.2s. There we go. There's some 2.2s. Red, gold. That'll do. I'll just put some 2.2s. It's fine. That's what was used from factory, so we'll just stick with that. I could just put some 10s. That would be like the most obvious like middle ground, wouldn't it? Shall I just put some 10s? Let's put some 10s. You make me happy when I watch your channel. I'm trying to learn your patience. Man, I appreciate that. That's really cool to hear. I wouldn't say I've got patience. Maybe I've got patience. I just hate being beaten. I don't like being beaten. I'm a problem solver. That's what I really thrive on, is problem solving. So I hate being beaten by stuff. So it's more of like just, yeah, persistence, I guess. Not willing to be beaten by stuff. I don't think it's patience per se. So yeah, the audio pipe, finished all the mods. I had to do a lot of work on that actually, modification wise. Especially getting the transformer frequency changed, because it uses a microcontroller with a fixed frequency. So I had to do some interesting stuff with the TL494 whilst retaining protection mode and soft start health check. It was pretty interesting. It was a good challenge of my knowledge. At 7 volts of input it's not there, only higher voltage and exactly maximum duty cycle it appears. Right, try this then, buddy. RTS. My suggestion would be to run... so, tell me what value gate resistors are being used at the moment. What value gate resistors are currently being used? Also, did you change the drive IC to something non-original? Where did I put it? Right, all new gate resistors. Let's just solder these in. Just tacking them in from the top, just so when I flip it upside down they don't all fall out. Yes, yes. I'm late getting back. Is that a Zeph board? Not sure. Class GH. It's a monoblock, sort of subwoofer oriented amplifier. from a UK brand, Vibe. Although they won't have designed it themselves, they would have had the design outsourced or whatever. So the power supply driver that I need is one of these. This is a NC34152. Let's take a quick look at that on the intervals. NC34152, I think that is. Oh, no, must have done that wrong. NC34152. Oh, I think it might be an M, not an N. There we go. What is the layout? Oh, this is basically just a 4427 by the looks of it. Yeah. It's exactly the same layout as a 4427. Okay. Do I have anything in this package that will work? What you see are most common in these amps. STM has a very simple user interface that uses drop-down menus for selecting SMPS timing. Sorry, bro. What do you mean? What you see? Is that? Do you mean what microcontroller family are most common? I changed them from 10 ohm to 100 ohm. Originally, it was using 4 BC327 for drive and 4 2N4401 for pull down, and using 12 RFP064s. I changed them with 772s. Yep. So basically, even with the 100 ohms, are you still getting the big spike? So what I was going to suggest is that you use like something like 47 ohm or 100 ohm gates, but you have a 4148 diode in parallel with the gate resistor, so that the pull down segment of the drive wave can bypass the gate resistor through the diode, but the turn on segment is through the resistor. And what that'll do is that'll actually slow down obviously slow down the turn on cycle of the FETs, hopefully, because basically the spike might be due to the duty cycle being a little bit too high, a bit too close to 50%, so you're getting some cross conduction. So by fitting a larger value gate resistor, you can mitigate that. Is this amplifier using a TL494, or is it using a microcontroller? You must be using a 494 if you said you changed the frequency. Straight up. So yeah, basically they were all using PIC 16 family, PIC 16F I think it is, for a long time. But now I don't have one within arm's reach. I don't know if they're using the PIC family anymore. This old ass one on the bench here, this is using PIC 30F. This great big chongus thing over here. Boris, hello Boris. How's it going, my friend? I was using 494. Yeah, you shouldn't be getting too close. Yeah, the 494 maxes out at like 48.9 something percent duty cycle, so it shouldn't be an issue. It must just be something to do with the transformer. So yeah, weird. What model of base phase is that one you're working on? So yeah, basically we can just drop in any sort of 4427 style compatible MOSFET driver here. But I don't know if I've got any that are in the large package like that. Let's have a peek in, nope, not in this drawer. I do have a donor board up in the loft for this, but I don't specifically want to use used parts if I can avoid it. So I might just have to order a new driver here. But let's see whether the microcontroller is okay. So let's plug a bit of power in and just see what this does. See if this gives pulses to the driver from the microcontroller. So we've got 12 volts on that side. There's a remote on there. And then we need to drop a fuse in because the fuses are all out. Do I have a random spare fuse laying around? Yeah, that'll do. Just need one fuse in there to bridge over the connections. Okay, so check for no solder bridges. We're good. And let's turn on the power supply, nice and low to start with, just in case there is anything shorting. 10.5 to start with. And we'll hit the remote and should see something come alive on the gate pad here. Possibly, depends on which driver's driving which bank. So the input should be this one right here, I think. Do we have any life? Okay, nothing so far. Okay, here we go. This MOSFET here, I think it's a transistor actually. This is definitely working. So are we getting any VCC to the drivers? Yes, we're getting VCC to the drivers. I'm not seeing any PWM going into this driver. Let's see what we've got going on over here at the MCU. Let's have a look. Do we have VCC over at the MCU? This is an LM7805, so we've got a 5 volt regulator over here. Okay, so this 5 volt reg is outputting 5 volts, that's good. That's probably for the PIC over here. Now in this one I'm not actually sure if the pulses are created by the PIC, by the MCU or not, but we don't have any signs of life from the PIC, but I haven't probed all of the pins. We've got some DC voltages on some of the pins. Yeah, we've just got an array of various different DC voltages there on the MCU. Now here we go. This is using a crystal oscillator. So if I can just see, there's a crystal oscillator there by the MCU. So we should get some oscillation on there, which we are not. So maybe crystal oscillator has failed, very unusual. FG7.3728. But yeah, nothing on the crystal, just DC. Interesting, so I wonder whether the crystal has failed. And that might have sent DC down to the gates of the power supply FETs, killing them. Interesting. Because yeah, I've got no life whatsoever on any of the power supply. Yeah, so I think for this one, needs new driver, and then potentially a new crystal oscillator, hopefully not a new microcontroller, because I don't know how you'd reverse engineer that without a working example to go by. Let's just check the output transistors. Now these ones on this board, they will read a low resistance between 1 and 3, that's just by design. So yeah, you've got 36 there, that's normal. 36, 36, 36, and then this right here, this is the MOSFET that switches the rails. This shouldn't have a short across it anywhere, which it doesn't. I think this one over here is like a final driver, so that doesn't have the 36. And let's go over to this side. 36, 36, 36, 36, and then another MOSFET over here for rail switching, should have no short. Yeah, that's fine. This is the final driver, so that's got no short. Yeah, so I think the output section on this is probably absolutely fine. And what I suspect happened is we had some kind of failure over in the MCU area. Either the crystal failed or the MCU failed, and that took out the power supply. Let's just do some multimeter tracing actually. Where do these drivers get their PWM from? So we have pin 2 and 4, which is logic input. So pin 2 here, we've got a resistor here. So I assume we go through the resistor. That resistor goes to ground, so it's not there. Where else do we go? Let's flip it over, have a look at the traces. I don't know if schematics exist for these. But we do have a lot of traces that go from the microcontroller all the way over here. However, I'm not really seeing a direct connection between the inputs of these drivers to the microcontroller. Let's just have another check, see whether we've got any connection. Ah, here we go. Yeah, we do have a direct connection from the drive IC to the microcontroller. So I wonder whether the microcontroller or the crystal oscillator failed, took out the power supply FETs and the driver, or whether the power supply died, took out the driver, and then the driver may have taken out the microcontroller. So I guess we'll have to wait and see when I get some parts ordered. But guys, let's read a quick bit of straight up can write any custom firmware for basically any UC. Pick old school, but the newer stuff is probably the STM8. I would actually love to get into that myself. I'd love to do a bit of research, and that'll be my next thing. Get into writing some microcontrollers. That'd be pretty cool. I recognise the phone jack interface on the board. This is a Zeph Arc Zapco produced board. Nice. Try looking for a Clarion DPX 1800 schematic. Thanks very much, Farrokh, for that advice. That's a good shout. I shall go in search of that and see what I can find. Something similar, just to get some references of. When you're on Jose's M21Ks. So with Jose, we have one of his, which I sorted out, which came from one of the ones that came from, I think, a guy called Jake, unfortunately had a shorted transformer, which is really annoying, bad luck. Like that bill should have probably been shared, but that's now sorted. The other ones which he sent in haven't either received them yet or haven't got to them yet, but as soon as they come in, I'm going to be jumping straight on them because I want to see what Joseph's build does. But yeah, be good to see. The output MOSFETs for those M21Ks are freaking costly. Let's have a look. IRFP 4868 PBF. So those amps use 12 of these. So if we're fitting 24, which is going to be 2 amps, that's going to be a 95 pounds in the pods, which I suppose isn't like the end of the world for 2 big 10k amps, but it seems like a lot for only like 12 FETs or 24 FETs. Yeah. Samuel, resilience is inspiring. I would have chucked it by now. Oh, it's cool, man. We haven't even barely got started on this one. Man, some of the stuff that I've battled with over the years. It's an exact clone of Baseface DB 1.4. Weird, because I haven't experienced those with like massive ringing or high idle current before. So I wonder whether it's actually a fault with the one that you're looking at, maybe like a incorrectly wound transformer, or maybe a transformer short to the core or something along those lines. Yeah, all of those ones that I've ever repaired, yeah, the power supplies have been fine. You can't probe an X-tile with a standard probe. The capacitance typically lows it down too much to oscillate. Oh, I have noticed that actually, yes. But, yeah, okay. Yeah, I have seen that before when I've like gone to probe a crystal oscillator with an amplifier that's kind of up and running. And then when you probe it, it kind of like messes up. So I did kind of gather that. But usually I can still see something. Usually I don't just see DC. But I'm not seeing anything on any of the other pins of the microcontroller, so something's definitely a little bit fishy there. And I have probed crystal oscillators before in the past and seen the waveform, you know, seen the frequency on the scope. So I'm pretty sure I should see something there. So I'm a bit suspect of that crystal there. Yeah, gents, it's been a pleasure. 10:30 in the evening here in the UK. Not too late, but I've been streaming for a while now. So I think we're going to lock and load it here. Gone through quite a few bits this evening. I've got a few parts to order to get some of these ones repaired and finished. Some 4427s in both surface mount and through hole. Got some Zeners to order. Got some IGBTs to order. Got some output FETs to order. On your Boot My Bus videos, you do the important impedance sweep, I think you mean, and look at the graph. What's the relation between the impedance and loudness, and what would be a good impedance graph look like? It's not as simple as that, I'm afraid, and there's no easy answer to that. It's not like this is good, this is bad. The impedance graph just tells you how the enclosure is loading the driver and the kind of interaction between the driver and the enclosure, and there's not really like a good or bad impedance sweep. It's not that simple. You can look at the impedance sweep of a sub in an enclosure, and from it you can tell like roughly what the thing is going to do. You can see, okay, you know, you got a massive impedance peak there, so chances are the driver's going to be heavily unloaded there. We've got a massive impedance null here, so either the driver's going to be heavily loaded or it's just really inefficient at that frequency due to the driver perhaps. So yeah, the impedance sweep doesn't really tell you how good it is per se. But yeah, guys, gonna lock it off here. Thanks so much for joining. Thank you for everyone who very, very kindly donated. Luna, looking at you specifically, thank you very much. That's very kind. Yeah, hopefully do some more streams a bit later on in the week. Get some more bits and bobs done, and I'm going to get the audio pipe mod in the heatsink. It's like just needs drilling a few holes, and then that's going to be a video that's coming out. I'm also going to do a video on some controversial stuff about car audio, like clipping, and I'm going to do a video on the 4 limits of a car audio system. I think that'd be pretty interesting for people to kind of to learn about. So yeah, take it easy, guys. Have a great rest of the week, and I'll see you all next time. Peace out.